Hey everybody, I just want to make a quick video for you. No one showed up, so this is just going to be me talking to the wall. In module 4, we were looking at logical operators in recursion. We did our comparison operators as well, and our stuff like that. But I wanted to look at recursion. I'm going to start with this one right here, this int factorial, because these are functions. So I'm going to pull up a document camera right here, and we're going to move it over to the side. Maybe I can move this a little bit. I like that. So we got int factorial, int n. So this thing takes in an integer. I'm off the screen. Takes in an integer and spits out an integer. And this thing is very much based on factorials. 5 factorial is 5 times 4 times 3 times 2 times 1. That's what this thing is doing. It's calculating it, and it's doing it in a method called recursion. So what it starts off doing is it starts off with something called the base case. The base case is like a stopping point for recursion. And that's with our if n equals 0. We were looking at ifs before. If n equals 0, it just says cout blast off. It does a cout, and that's it. That's all it does. And then, so like that's our base case. So if it does that, the program ends. Otherwise, the recursion part comes in the else. The else has a recursion. So what it does is it does a cout of n. I'll put blast off up here because when I run through the 5 one over there, then it does countdown n minus 1. Wait, sorry. I'm looking at the wrong damn thing. If n equals 0, return 1. Else, return n times factorial n minus 1. So that's our factorial program. So like in main, if I type in factorial or do like a cout factorial 5, what I'm expecting to get back is the results of this right here, which is 120. So what happens is we go in and we put in factorial 5, and it pushes into 5. So I say factorial 5. So it sends 5 into the box, n equals 5. It checks my if condition, if n equals 0, and it doesn't. So we do the else. We else return n, which is 5, times factorial 4. So factorial 4 makes it run up another box right here. N equals 4, not 0, so it's going to return 4 times factorial 3. And so this brings the next box, factorial 3, n equals 3. It's going to return, I'm going to abbreviate that as red, 3 times factorial 2. And factorial 2, didn't give myself a lot of room on this paper. N equals 2 is also not n equals 0. So we're going to return 2 times factorial 1. Then we've got factorial 1 here. N equals 1. It's going to return 1 times factorial 0. And finally, factorial 0, we've got n equals 0. This triggers the if case. So this returns a 1. So a 1 is sent back to this program. And this is called the stack. This is called the stack. It's in memory. It's each of these is running. This runs this, this runs this, this runs this. This one can't finish running until these get finished. So it adds up in a stack in memory. You will talk about this a lot more in CSCI 2. But it returns a 1. We get to this one. This does 1 times 1, and it returns that. So it returns a 1 also. And that's factorial 1. So factorial 1 is a 1. As these finish off, they close off the memory. They clear the memory. This returns 2 times 1, so it returns a 2. When it returns the 2, it closes off the memory. It's a 2 right there. We still have 3 times that. So 3 times 2 is 6. It returns 6, which is 3 times 2 times 1. So now we've got 4 times 6, which is 4 times 3 times 2 times 1. 4 times 6 is 24. It returns 24 up here. And that's the factorial 4. So we have 5 times 24 is 120. It returns 120 to the main. That program ends in the main. And in the factorial, on screen, we see, all we said is C out factorial 5. All we see is 120. So that's how recursion works. Programs keep calling themselves. A recursive program calls itself until it hits the base case. Okay. What we did right here, what I did on paper, is called a recursive trace. That's something you're going to need to know how to do in CSCI 2, but we will cover it a lot more in CSCI 2. And I probably introduced it a little more than Redden does. I don't know that he actually does the full trace right now, but I think seeing it now, so when you see it again, it's effective. So we could take a look at this countdown thing over here. And countdown, I'm just gonna, we can see it on the screen. So I'm just gonna say we do countdown 4. That's what I call in main. So I do countdown 4 in main, and so here's my screen, my output screen. And over here, we're going to do the trace over here. So we send in 4. And it's going in as n. Int n. So n equals 4. So n equals 4. The if case is a no. So we get to the else. And there's stuff going on here. Else, first off, we see out n. So we see out 4. So this is going to put a 4 on the screen. And then it runs countdown n-1, which is 3. It doesn't finish the rest of the program. It does not do the cout after call yet. It immediately skips doing the rest of the program and comes down here and does n equals 3. The if is no, so else it does a cout of n, cout 3, it's going to put the 3. It does countdown 2, which sends us into a new memory block. A new program is running in the stack. N equals 2. Again, the if is not passed, so it does an else cout 2. We get down to the countdown n-1. This is countdown 1, which is also a new box. N equals 1. It says if n equals 0, we're still not at the if case. So it's going to cout a 1. And it's going to do countdown 0. Countdown 0 to keep it all on the screen. I'm going to do it over here. N equals 0. The if case is a yes. So it does the blast off. Everything else, the else does nothing. Not run. Because it's an if or an else. So after that one's done, this closes off. And it returns to the line right after countdown 0. And does cout after call n. So here it should say after call. And n is 1 right there. Then that program finishes. And it comes up to right here. Countdown 1 is finished running. Now it does the cout after call again here. Cout after call n here. N equals 2, so it says after call 2. This program finishes, goes back up to countdown 2. This was countdown 2. It goes back up to the line that called it, and it goes to the next one, cout after call. And we're doing n again, which is 3 here. So we got after call 3. And you can see this goes up to here, and it does it here, after call 4. And when we do after call here 4, the very program we started with finishes, and countdown 4, this line ends, and it goes to the next line in the program, if there was more of the next line in the program. But this is what's going to be put to the screen. So recursion calls itself, or further instances of itself. This is get you a sample of how it works. Again, this is a recursive trace. Have fun exploring the assignments and stuff. Peace.